morning, welcome to all. This is Tanu Gupta from IT department in Akgec Engineering College. Today I'm going to present a very important topic or to discuss a very important topic in machine learning technique, that is Perceptron and its training rule in artificial neural network. So first we understand what is Perceptron. Perceptron is one of the simplest artificial neural network architecture introduced by Frank in 1957. It is primarily used for binary classification. As we already discussed about the topic artificial neural network in our previous lectures, that binary classifications means when the output is in the form binary, 0 and 1, true and false, and either on case yes or no. So yes, Perceptron is the simplest artificial neural network architecture. Perceptron is a type of neural network that perform binary classification and map input feature to an output decision, usually classifying data into one of the two categories, 0 or 1. Perceptron consists of single layer of input node that are fully connected to a layer of output node. As we already discussed the concept of input layer, these are some nodes in input layer and the output layer. Every node in the input layer is connected to the output layer. This is an input layer and this is a output layer. So every node in the input layer is connected to the every node to the output layer. So network is fully connected. It is particularly good for at a learning or linearly separable data. Single layer perceptron is basically used for linearly separable patterns, like if we want to separate our data into two classes. So if we easily separate that data into the linearly separable. For example, if we have two classes, for example, like this, and we have to separate our data by a single straight line. So when we have the two classes which are separated by a straight line, so under this concept, single layer perceptron is basically used. Now types of perceptron: single layer perceptron and multi-layer perceptron. Single layer perceptron, in which there are two layers, input layers and output layer, and the input neurons in the input layer is connected to the output layer neurons and the network is fully connected. It is effective for tasks where the data can be divided into distinct categories through a straight line. While powerful in its simplicity, it is struggle more complex problem. If we have large data set or we have a complex problems, then single layer perceptron has a disadvantage to perform accurately. Multi-layer perceptron possess enhanced processing capability as they consist two or more layer input layers and one or more hidden layers, adopt and handling more complex pattern. If we have a large data set and complex pattern, then we use a multi-layer perceptron to solve our problem. Okay, so first we understand the basic concept of perceptron in artificial neural network. A perceptron is composed of key components that work together to process information and make predictions. So perceptron has a various components that work together to process the information and make prediction. First is input features. What are the input features? The perceptron takes multiple input features, each representing a characteristics of input data. In the input features, we have a number of nodes that represent our multiple input features of that input data, that represent the features of the input data or the characteristics of input data. Weight. Second one is weight. Each input features is assigned a weight that determine its influence on the output. Each input features has assigned a weight. Every node has a weight. As we discussed already, every input has weight and that weights determine that node, how that node influence the output. So we use that weight according to that scenario. These weights are adjusted during training to find the optimal value, and these weights can be adjusted to find the optimal value. Now, the summation function. Summation function, the perceptron calculates the weighted sum of its input, combining them with their respective weight. Now, the activation function. The weighted sum is passed. Now, the weighted sum is passed through the activation function, which can be any activation function like Heaviside step function, sigmoid, 10H, ReLU activation function, and so on, comparing it to the threshold to produce a binary output, that is a 0 and 1. So, the next one is activation function. Now, finally, the output. The final output is determined by the activation function. So, the final output of our data is determined by the activation function. What is the value of activation function? That will be the value of our use to make the prediction. Often, it is used for binary task. Now, bias. Bias term help the perceptron make the adjustment independent of the input. Bias is a constant value that we make use for the adjustment of weights and inputs that is independent of the input. That is improving the flexibility in learning. Now, the learning algorithm. The perceptron adjusts its base, weight and bias using a learning algorithm. Now, the perceptron, how the perceptron adjusts its weight and bias? Using a learning algorithm such as a perceptron training rule to minimize the prediction error. And what is the perceptron learning rule? We will discuss later after this slide also. Now, as we discuss what is the activation function determine the output of a node for the given set of input. Without them, the network is behave like a linear regression model. If we are not going to use linear activation functions, these are the various activation function, then our model will behave like a linear regression model, which we have an input as we produce as an output. So there is no changes the input weight, then it is we get our output regardless of how many layers it has. If we are not going to use activation function, then how many layers in the in our artificial neural network doesn't matter. We have the following activation functions that we are going to use in the single or multi-layer perceptron. Sigmoid activation function, 10H activation function, ReLU rectified linear unit, leaky ReLU and softmax activation function. The formula for the sigmoid activation function is given by that formula, then 10H f of x maximum of 0x, 0.01 and then so on, and its output is considered in the following range. So, if we apply the activation function at the hidden layer, typically we use a ReLU and leaky ReLU or its variant. At the output layer, we use a sigmoid function for binary classification about data. We have output value in case of binary, then we use a sigmoid function, softmax for multi-class and linear for regression task. This is a diagram for the perceptron, case of single layer perceptron. X1, X2, X3, Xn. X1, X2, X3, Xn are the features, or we can say are nodes in the input layers, or we can say a characteristics of our data. W1, W3, so on, Wn are the weight assigned to that node or that features which influence the output. Now we discuss the term summation function x1 w1 plus x2 w2 x3 w3 plus xn wn. This is a summation function, total input that we collected. Now net sum, through this formula fx is equal to summation of xi and wi. We will calculate the net sum. Then we apply the activation function to get the output. So as we discuss activation function, we use activation function to produce output or to make the predictions using the net sum. This is a bias we discuss. It is a constant value which is independent of the input, and we use the bias to adjust our weights and so on. Now we compare the net sum with the threshold value, and then we produce a output that we will denote it by y is equal to output. So this is a basic approach we follow in single layer perceptron model in artificial neural network. This is a basic approach that we followed to make prediction in the artificial neural network. As we discussed, the perceptron consists of 4 steps: input from other neurons, weight and bias, net sum, activation function. In this case, we use a step-up function. Have you said a step-up function? If the activation function that we will denoted by fx is greater than equal to the threshold value, then the output is equal to 1, because the single layer perceptron is basically used for binary classification model. If the function of x value that we will get from this is less than the threshold value, then the output will be 0. So according to this step-up function, we will calculate the value of our output using the single layer perceptron and for making a prediction. So this is a basic concept of artificial neural network perceptron, so that we can classify our data according to this approach. Now, yes, set the initial weight as we discussed in the diagram also. For example, if we have 3 neurons in the input layers and 2 neurons in the output layer, and each neuron in the input layer is fully connected to the each neuron of the output layer. This is the input layer and this is a output layer. We denote this node by x1, x2, x3, w1, w2, w3. Like if we use 4, 5, then w1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. So bias, we use our weight w1, w2 and wn, bias theta to our red value in our range -5 to 0.5. Compute the weighted sum by multiplying the input. How we can compute the weight? By multiplying the input weight to the input value to the weight and add the product. For this, we get the net sum. Apply the activation function on the weighted sum. Now, we apply the activation function on the weighted sum. So this is a net value we have calculated minus threshold value, and for this value we will calculate the activation function. Then we will get a value of y, that is our output. If the sum is above the threshold value, if the sum is above the threshold value, the output value is as positive as we discussed in the previous slide. If the value of y is greater than equal to is threshold value, then output will be 1. If else, the output is negative. Okay. Calculate the error by subtracting the estimated output y estimated from the desired output. If we have to calculate the error, this is actually a perceptron learning rule. If we want to calculate the error, there is a predicted output and there is a expected output. Okay, desired output, or we can say a y desired is going to tell like that we want that output, and according to our model we will get this output y estimated. So if there is a difference between that expected and the desired, then it is shown as error. Calculate the error by subtracting the estimated output from the desired output. So this is how we calculate the error between the desired and the expected output. Update the weight if there is an error. If we found the error between the expected and the desired output, so according to the perceptron learning rule, we have to adjust the weight. So how we adjust our weight? Delta W of I is equal to alpha, that is known as a learning rate, E of t is a error, and xi is a input. And then we add this weight to that weight for calculating the updated weight, where xi is a input value, et is a error at a step t, alpha is a learning rate which is a constant value, and delta wi is a difference in weight that we have to add it to wi. Delta wi is a difference in weight that has to be added to the wi. Wi is a initial weight and this is a changes in weight. Okay, so this is a perceptron learning rule. Like yes, if we are going to show a perceptron learning, one way to learn an acceptable weight vector is to begin with random weight. First of all, how we start our question is to begin with random weight, then iteratively applying the perceptron to each training example, modify the perceptron weight whenever it misclassify an example. This process is repeated through the training example as many times as needed until the perceptron classify all the training example correctly. Weights are modified at each step according to the perceptron training rule, which revises the weight wi associated with xi. So how we calculate our wi is equal to wi plus delta wi, and delta wi is equal to learning rate error multiplied by the input weight. So this show a algorithm of perceptron training rule, that we use weight I as a small random value. For each instant x, compute the real output value of y, that is activation function. If the desired output is not equal to the expected output, then for each wi we calculate the updated weight and for and if until all the training instances are correctly classified. until all they classify. Okay. So these are the limitations of perceptron. It is limited to only the linearly separable problems, the problems which are linearly separable, that we are going to use a single layer perceptron. Struggle with convergence when handling non-separable data, requires labeled data for training, which is very complex for the overall working of that. Sensitive to the input scaling. If we use a incorrect weight or input scaling, then we also get a incorrect output for the prediction. Lack hidden layer for complex decision making, because in the single layer perceptron there is no hidden layer, there are only two layers, single layer and output layer. So for the complex decision making, the single layer perceptron is not show accurate result as comparison to the other approaches that we are going to use. Okay, now let us take an example to how we calculate our predicted output if we have a data. For example, if we have a 3 input nodes, or we can say our neurons, or we can say our features and characteristics in the input layer, x1, x2, x3, which has some weight 1, 2, 3. Okay. X1 has a weight 0.5, x2 has a weight 0.4 and x3 has a weight 0.3. The value of x1 is 1, the value of x2 is 2 and the value of x3 is 3. The value of W1 is 0.5, W2 0.2 and 0.3. Then you have to calculate the output. So how we can calculate the output? First we have to calculate the net sum. How we calculate the net sum? Summation of xi and wi. So 1 multiply 0.5 plus 2 multiply 0.4 plus 3 multiply 0.3. So that is how we calculate the input sum according to that diagram. Okay. Now if we want to adjust the bias value, we have to subtract from it. Okay, for example, if we have bias like 1, then we subtract the bias from this value and we got this value. And after that, we calculate according to this. We have to apply a activation function. Activation function, if the function has a value greater than and equal to the threshold value, which is equal to 1, then the output will be 1. If the f of x has a value is greater than less than equal to 1, then the function of x has a value 0. So according to this, we have to classify our data into the two categories, 0 and 1, because single layer perceptron is best suitable for the binary classification problems. So according to this, we are going to use a single layer perceptron in which the data we have the linearly separable data. Okay, that's for now in the perceptron in the artificial neural network. In the next lecture, we are going to discuss our topic in the multi-layer perceptron learning algorithm. Thank you so much. That's it for now. Have a good day.